The offices and the process building are connected, and then directly behind the process building is the tank farm. There are 16 tanks for the storage of waste oil products and the various products that are produced on the oil side of the system. You can see the exhaust fans protruding through the side of the building. The blow-off box surge tank is that gray tank with the 3 16-inch lines coming into it. The waste oil is delivered by tank truck to the tank farm storage building. 10 tanks are dedicated to the storage of the feedstock, and 6 tanks are dedicated to the storage of the 2 different types of product that is produced by the system. The product is pumped into the tanks with 2 gear pumps, and the finished product is pumped to the overhead loading arm by a centrifugal product pump through a meter. The product is transferred from the tank farm to the process building through an underground pipe trench. The feedstock is pumped through the pipe trench into the day tanks that you see located along the wall on the left side of the picture. This is where the feed pumps for the system take their suction. There's 1 3,000-gallon burner fuel tank and 2 5,000-gallon storage tanks, 1 for the 320 system and 1 for the 510 system. You can see the condenser units for the 2 320 systems directly in front of us. The cracking pots are behind the condensers, and in the center of the picture is the cracking pot for the 510 unit. The first part of the process is the pre-treater. The waste oil is fed through this pre-treater where it is preheated and dehydrated before being pumped into the 510 cracking pot. The discharge from the pre-treater flows through piping to an insulated 3,000-gallon oil tank. This tank serves as a feed tank for the 510 preprocessor. The dehydrated oil tank is located beside the cracking pot of the 510 preprocessor unit. Here the oil is heated uniformly, and the different grades that make up the concoction of waste oil are volatilized and flow naturally into the condenser unit. This is the condenser section of the 510 unit. The oil vapor flows through the insulated tower into the condenser tubes where it is recondensed. At this point, the fuel is either suitable to be burned in an industrial type burner with an atomizing tip, or a medium or slow speed diesel engine. The third use for the product is to refine the process a little further by running it into using it as feedstock for the 320 units. There are 2 320 units located at this facility, and the oil coming from the 510 unit is used as a feedstock for these units. What these units do is improve the quality of the fuel to make it suitable as a replacement for a number 2 diesel. These are the 320 condenser units. This is where the oil vapor is recondensed back into a liquid after passing through the 320 process. There are 2 of these units at this site. You see the ductwork for the cooling fans. The fuel that is collected in the 320 condensers is pumped into an intermediate tank where the stabilization additive is metered in, and from this tank they are pumped into the reaction tanks, the green tanks located directly behind the heat exchangers. And once the fuel has remained in these tanks for a certain period of time, it is then sampled. The sample is checked in the lab, and the fuel is pumped to the tank farm for storage prior to being sent to the customer. Here we have the 2 5,000-gallon stabilization tanks. From these tanks through a separate pump, the final product is pumped to the tank farm, as I said before. At this particular site, we have an OCD room which holds the stripping vane separators, which are part of the odor control device. This room in this situation had to be completely explosion proof because they're inside. However, this would not be necessary if this equipment was located outside the building. These are the 4 stripping vane separator units, 1 for each condenser, and their associated pumps. Any non-condensable gases that are not condensed in the heat exchanger travel through pipe to these stripping vane separators, where the maximum amount of liquid is extracted, and any further vapor remaining goes through the wall out to the OCD stacks, which are located outside the building. There are pumps located along the wall for removal of condensate and any water. That may be present in the vapor. Here you see the spark arrestor and stack arrangements where any non-condensables are combusted to prevent any odor of any kind leaving the site. They are equipped with UV scanners and gas pilots to ensure that at any time there is gas present at the nozzle, it is ignited and burned cleanly. The spark arrestors prevent any gases from returning and burning back into the system. They're a safety feature that must be included in any type of installation like this. There are 2 on each stack. In the event that one becomes dirty in the middle of the run, the operator changes the valves over and switches to the spare that's in line. The pump room contains the pumps that are used to transfer the feedstock from the tank farm building to the various equipment. The larger pumps are located in this room, and with the connected piping give us a great deal of versatility in the products pumped in many different directions. This is the control room. On your left you see the PLC control panels which control the oil refining equipment. All the emergencies, the inputs, and computer links are located in these panels. On the right we have the circuit breakers, and directly ahead of me is the operator's desk. The operator interfaces with the system through the computer located on the left side of the desk here in front of the window. There are 8 separate screens on which the operator can bring up to monitor the temperatures and pressures and which pumps are in operation, etc., throughout the whole operation. Our system consists of a main menu, the system override 3001, 3002, 5001, the tank farm, the stripping vane separators, the day storage tanks, the PID controls, printer control bits, and the I/O status. This is the operating screen for the 320 systems. Each 320 unit has its own screen with the controls for burner fire, automatic set points, and the operator can control various pumps and burners directly from this screen. This is the screen for the 510 unit. Now we're looking at the screen that is displayed for the operation of the pre-treater, where the oil is initially dehydrated and preheated. This screen gives us an overview of the day tanks and will indicate the level in gallons in the day tanks and alarm points both high and low. It will also indicate which pumps are running and which pumps are off. This is the tank farm screen. Each of the 16 tanks has a Miltronic sensor in it, which will give you a readout showing the level in each tank and what product is in the tank. And this is the screen that the operator uses to monitor the operation of the OCD stripping vane separators and associated pipe, and the OCD stacks with their pilots and main burner nozzles. This is the system overview screen, which has all the units, the tank farm, day tanks, and the separators on it, and all pertinent information can be obtained concerning pressures, temperatures, and levels directly from this screen for the whole total package. This panel is the combustion control panel. It contains all the controls and the units required to interface between the burners located on the units and the computer. It allows the operator to modulate the fire and control the temperature of the oil to within 1 degree throughout the oil. Here we have two bottles. The bottle on the left of each group contains the waste oil product that was delivered to the plant. The bottle on the right contains the fuel that was produced by the equipment. As you can see, the sample, the group on the right, had a high content of water and solids.